The solution of a triangle using sine and cosine rules. The sine rule is easier than the cosine rule, so try to use it first if possible. When solving a triangle, it is advisable to use cosine rule once and then use the sine rule to complement the cosine rule. So in this lesson, we're going to look at the need to solve a given triangle completely using both the sine rule and the cosine rule. When given a triangle such as triangle drawn on the board is A, B, C, and we have here to be 40.8 degrees, and we have here to be 7.3 centimeters. Oh, okay, let's see. We have here to be 7.3 centimeters, and then we have here to be C. We have here to be, if this angle is given to us, and assuming that this angle is given to us as 40, okay, let's say 74 degrees, assuming it is 74 degrees, and side A is also given. Okay, side A is not given. So in this case, you can see that two angles given and one side where the side that's given is opposite a given angle. So you see that this condition fulfills the sine rule. The sine rule is fulfilled here, so we make use of the sine rule in this case. But there are times that the triangle given to us does not meet this condition. So we can have something like this. We can have A, B, C, and we have here, let's say 9.7 centimeters, 7.3 centimeters, and 10.4 centimeters. Oh, okay. And then we have an included angle 48.9 degrees. Then we have B. And we're told to solve this completely, this triangle completely. So what do? Look at it. We must start with either the sine rule or the cosine rule. So from what we can see on the diagram, the condition that is met here is the condition of using the cosine rule, because we have an included angle and two given sides, where the included angle is between the given sides, the two given sides. So we use the cosine rule to look for B first. Yeah, once we use the cosine rule to look for B, then the next thing is to use the sine rule. So that's the implication of this right. So the sine rule is easier than the cosine rule, so try to use it first if possible. So in this case, we can't use the sine rule because it's not possible to use the sine rule first. But if it were possible for us to use the sine rule first, which in this case it is, because the included angle given to us here are 2 and the given side, and this fulfills the sine rule condition. So in this case, we must use the sine rule first to get this given side, which is C. So once we get this given side, we can use angle sum to get this side. Then we can use cosine rule to get the third side, or we can also use the sine rule again to get this third side. But for this particular case, where it's not possible for us to use the sine rule first, we need to use the cosine rule to look for side B, which is this side. And once we use the cosine rule to get this side, we shouldn't use it anymore. Rather, we should use the sine rule to get one of the angles, either this angle or this angle. And once we are able to do that, we can use the angle subproperty to get the third angle. In that way, we have solved the triangle completely. So there are questions on triangles that warrant that we use both the sine and cosine rules. However, there are rules that guide or must guide us on which of them we should use first, and these are the rules that I just explained. That's the first part of the rules that I've just explained. First, and that rule is that first ensure or try to figure out if you can use the sine rule first by looking at the diagram or the triangle. If the sine rule is applicable, if the sine rule is not applicable, then use the cosine rule, and that means that that will be the first and the only time you're going to use the cosine rule. And after that, you can use the sine rule. And then when you are using the sine rule, so like if the condition of the triangle you are going to calculate falls into this category where you must use the cosine rule first. After using the cosine rule and you want to use the sine rule, the steps you need to take before you calculate for any of the angles is that you must first of all calculate the smallest angle, So assuming we use the cosine rule to look for B, and we discover that B is say 10.7 centimeters. So you can see that B in this case obviously seems to be the largest angle, so side B would be the longest side. So the smallest side will now be 7.3, so you must look for this angle first, which is acute. Then the third angle would be also be looked for next, and you can use the angle sum to get the third angle. So I was okay. So let's go to examples that will use all these principles. But this is just for explanation. So I tell we start taking examples, all these principles will be applied, and at the end of the example, I will write down the observations and the rules or the principles that are applied in each step while we are carrying out the calculation. So in triangle ABC, B is 4.2 centimeters, C is equal to 7.5 centimeters, and A is equal to 48 degrees 36 minutes. Solve the triangle completely. So what you're going to observe when you look at the triangle drawn on the board from this information given is that the triangle here fulfills the cosine condition, the first condition for cosine rule, that is two given sides and an included angle. And the two sides are between the included angle, and then we have a third side. Now we were not given any angle, neither angle C nor angle B. So at this point we cannot use the sine rule because it's not going to be possible. So we're going to use the cosine rule, and once we use the cosine rule, from what I explained before taking this example, this will be the only time that we're going to use the cosine rule in this particular triangle. So first thing first, in any triangle, first try to analyze if the sine rule is possible to be used. If it's possible for you to use the sine rule, then use it first before you use the cosine rule. But if it's not possible, then use the cosine rule and then use the sine rule thereafter. But make sure that in your calculation you are using the cosine rule only once. And when you are using the sine rule, first analyze the triangle to find out the smallest side and look for the angle of the smallest angle first before you look for the biggest, the largest angle, in order to avoid ambiguity. Okay, so first thing, let's solve. Okay, so we discover that angle A is given in degrees and minutes. So we have that 48 degrees 36 minutes. And from our conversion, 60 minutes equal to 1 degrees. And so here we have 36 minutes. So we're going to look for the equivalent of 36 minutes in degrees. 36 minutes is equal to x. So what do? We cross multiply. So 36 times x. 36 minutes equal to 60x. And then x equal to 36 divided by 60. And this will give us a calculator. 36 divided by 60, 0.6 degrees. So you're going to add this to 48 degrees. So this will give us 48 degrees plus 0.6 degrees, which is equal to 48.6 degrees. So our answer here is equal to 48.6 degrees. That's angle A in degrees fully. Here is just here angle when it was given to us initially, it was both in degrees and minutes, but in degrees fully it will be 48.6. So from here we're going to use the cosine rule. So we're going to say using the cosine rule, Now what are we looking for? We're looking for BC, which is A. So A squared is equal to B squared plus C squared minus 2BC cos A. So substituting into the formula, A squared is equal to B squared is 4.2 squared plus 7.5 squared minus 2 times 4.2 times 7.5 times 7.5 times cos 48.6 degrees. Cos 48.6 degrees. And so A squared is equal to 4.2 squared 17.64, 7.5 squared 56.25 minus 2 times 4.2 times 7.5 times cos 48.6, 41.66, 44, 41, 41.66. I'm rounding off this. Okay, I'm approximating this value to the nearest two decimal places. You could increase just plus 4 or to the nearest whole number, but also whatever number of decimal places you approximate to, remember that's going to affect the final result one way or the other, so be careful about that. So A squared, usually you should leave it in 4 figure until you go to your final answer before you approximate. A squared 17.64 plus 56.25 minus 41.66, 32.23, 32.23. So A, taking square root of both sides, will give us 32.23. This will give us 0. So square root sign to give us square root of 32. 5.677, 5.677. So A is equal to 5.68. Since here the figures here are in the nearest one decimal place, I'm going to say 5.7 centimeters to 1 dp. So that's the value of A. So from here we determine the value of A. Now, since we're going to use the sine rule, and like I said earlier, when we are going to use the sine rule, the next thing or the next principle that should be applicable in cases like this is that first use the sine rule to solve for the smallest angle, and the smallest angle is always opposite to the smallest side, while the largest angle is always opposite to the largest side, or the longest side rather. So now that we got the value of A to be 5.7, so we know that 7.5, 5.7, 4.2, the smallest is 4.2. So the angle opposite to 4.2 is angle B. So we're going to say using the sine rule, so we are going to use the angle and the side that is known again versus the angle and the side of which one of them is not known. So sine A and sine A is known. So sine A is equal to, and we're looking for angle B, so sine B over B. So let's put our values. Sine 48.6 degrees over A, which is 5 points. I can use this approximated value, but let me use this the real value I got from calculation. 5.677 equals to sine B over B side B, which is 4.2. So sine B is equal to 4.2 sine 48.6 degrees over 5.677. So sine B is equal to 4.2 sine 48.6 divided by 5.677, 0.55, 0.5550. So B is equal to arc sine 0.5550. Angle B is equal to 33.71 degrees. Okay, so we've gotten the angle B, and of course angle A was given to us, and then we've gotten angle B. Now we need to get angle C. So to get angle C, I'm going to say from the angle sum property, of triangles, angle A is equal to 180 degrees minus 48.6 degrees plus 33.71 degrees. And the reason is that sum of angles in triangle. That's the reason. Sum of angles in triangle. State your reason. So A is equal to 180 degrees minus 48.6 plus 33.71, 82.31 degrees. And A is equal to 180 minus 82.31, 97.69 degrees. So angle A, the value of angle C, angle C. So the value of angle C is equal to 97.69 degrees. These are final answers, but discover that the angle that was given to us in the question was in degrees and in minutes. So we must leave our answers, final answers, in that form as well. So answers correct to nearest minute. Give us the angle A is 40. Since A was, we didn't calculate for E. B is equal to 33. Already 33 is in degrees. 33 degrees. So it is 33.71. This is how we go about it. We split this to give us this whole number parts to give us our degrees, then this will give us 0.71. So it was this what we have here that was added to give us this. So 33 degrees, 0.71 times 60. So you multiply this fraction, this decimal, by 60. Why do we do that? Why do we need to do that? Because from our analysis here, when we converted from minutes to degrees, we know that 60 minutes is equal to 1 degrees. And now 0.7, so we want to get the value of 0.71 degrees in minutes. So we say x minutes is equal to 0.71 degrees. When we cross multiply, x times this will give us x, 0.71 times 60 to give us the value of this in minutes. So 0.71 42.6. Since we need to approximate it to the nearest minute, this will give us 43 minutes. So this will give us 33 degrees, 43 minutes. And then C is equal to 97 degrees, 7 degrees. Still same process. Now give us 0.69 times 60 degrees. So 0.69 times 60, 41.4. That's got 41.4 and approximately 41 minutes. 97 degrees, 41 minutes. So those are the answers correct to nearest minutes. So this is what you need to note whenever you are going to solve a triangle completely. And for you to solve a triangle completely, it means you are going to need both the sine and cosine rule. So this note is that, especially from this example, so in the example above, and it also applies to other examples where you need to solve the triangle completely, where you might use or where you are going to need both the sine and cosine rules to do that. So in the example above, we used the cosine rule first to find A. That was because from the analysis of this diagram, only the cosine rule was met, and for you to begin, you must start with the cosine rule and you have to get here. So we use the cosine rule first. So if you analyze the diagram and discover that cosine rule is not met, so it was the sine rule that you needed to use first, then use the sine rule first, then continue. Okay. So then the sine rule to find the next angle. Okay, so to avoid ambiguity, always calculate the smaller of the two remaining angles first, since this angle must be acute. So I have to come to this side, because if I continue like this part of the block will not be enough. So that's why I have to clean up this marker right from here. So to avoid ambiguity, always calculate the smaller of the two remaining angles first, since this angle must be acute. The smaller angle is opposite the smaller side. So about ambiguity, there's a video on the ambiguous case, so you can go back to that and watch to know what it means and how to, not that you are going to avoid it necessarily, but there's a way you go about it. So but when you are solving for sine and when you're solving for a triangle completely using the sine and cosine rules, you deliberately need to avoid that case. And to do that, that's why I reiterated at the beginning that after you have used the cosine rule, analyze the diagram because by the time you have used the cosine rule to look for the third side, you must have known the three sides of the triangle. So from there you can deduce which side is the longest and which side is the smallest. So once you have done that, use the sine rule to solve for the angle facing the smallest side. So because the smallest side is facing the smallest angle, so first get the angle facing the smallest side, which is acute, and then use the angle sum property to look for the third angle. But if you choose not to use the angle property, you can still go on to use the sine rule again to get the third angle, and you get the same answer. So ensure that you follow these rules that are noted here, and you won't miss it nor go wrong whenever you are solving a triangle completely using the sine and cosine rules. So let's take some examples more. In triangle ABC, A is equal to 6.7 centimeters, C is equal to 2.3 centimeters, and B is equal to 46.6 degrees. Find B, A, and C. So the first thing we need to do is to sketch our diagram. And we don't just put the letters. We're going to read the question to know where to put our letters. Since B is 46 degrees, 46.6 degrees, apparently B could be the smallest, but I'm seeing C to 2.3 centimeters. So let me just leave B here. I'm going to put B here. And I'm seeing A to the 6.7. So this should be the longest side. So let me put A here and then C. So, okay. So B is 46.6 degrees, 6.6 degrees, and I'm going to look for B. A is 6.7 centimeters, 6.7 centimeters. C is 2.2 centimeters. So what do you notice? If you have been following, you would know that this is a condition of using the cosine rule, and that means we're going to look for this side, which question we should do. Find B. So using the cosine rule first, since that's the only way we can begin. Using the cosine rule, B squared is equal to A squared plus C squared minus 2AC cos B. So B squared is equal to A is 6.7, and then go to B squared equals to 6.7 squared plus 2.3 squared minus 2 times 6.7 times 2.3 plus 46.6 degrees. $44.89 plus 2.3 squared 5.29 minus 21 is 1.8. 44.89 plus 5.29 50.18 minus 21.18. So 50.18 minus 21.18, that's 29. 9.0. So first, taking square root of both sides, taking square root of both sides, that gives us root B squared equals to root 29.0. And this two cancel the sign. B is equal to square root of 29.0. So B is equal to root 29. 5.385. Our answers here are in two significant figures, so minus on the left, approximately 5.39. Oh, yeah, 5.4 centimeters. So two significant figures. Side B is 5.4 centimeters, so two significant figures. Next thing to do is to solve for the next angle. So now that we know the value of B, let's see which side is the smaller side. Is it, to you, is it here or here or here? Your guess is right. I think it's here. This is the smallest side. So the smallest angle definitely is C. So using the cosine, using the sine rule, rather, using the sine rule, and we're going to use the ratio of an angle that is known to a side that is known, which is sine B. So B, sine B is equal to the ratio of an unknown angle to a known side, which is C, sine C over C, 2.0. So sine C, okay, no value yet. So sine B is sine 46.6 degrees over B, which is 5.385 equals to sine C over C 2.3. Or let me just say this. I use this value instead of this estimated or approximated value. Usually, in most cases, it's advisable to use the figure that was not approximated when you are calculating. If need be, that you need to use that value further in calculation. But sometimes some persons use this value, but it's usually advisable to use this value, not this. So let's go. Sine C is equal to 2.3 sine 46.6 degrees over 5.385 sine C is equal to 2.3 sine 46.6. That is 1.67 divided by 5.385, 0.3103. So C is equal to arc sine 0.3103, and C is equal to shift 0.3103, 18.08 degrees. 18.08 degrees. So the value of C is 18.08 degrees. Now to get angle A, so A is equal to 180 degrees minus 46.6 degrees plus 18 points. I'm thinking of using approximating this value to 1 dp, this in degrees, because what I have here is for 6.6 degrees, so approximately C is equal to 18.1 degrees, so that can be uniform. 18.1 degrees, and then so this is equal to, okay, so I think I just said that you shouldn't use the approximated value until the end of the calculation. So let me do this one. 18.08 degrees. What's the reason? The reason is sum of angles in triangle. That's the reason. That's equal to 180 degrees minus 46.6 plus 18.08, 64.68. 64.68 degrees. That will give us 180 degrees minus 64.68 degrees, 115.32. 15.32 degrees. That is the final answer, and that is the value for angle E. The diagram below shows three girders forming a crane XYZ. So this is the first one, the second girder, the third girder. So the three of them are forming a crane XYZ, lifting a load L from the horizontal ground, and xy is vertical. Xy is vertical, and xy is vertical. Xy is equal to 14 meters, y z is 12 meters, and x angle y z, that's the angle between x and z, which is y, is equal to 110 degrees. So A, calculate the angle between xz and xy. The angle between xz and xy, this is line xz and this is line xy. The angle between xz will be this angle. Take note of that. Okay, xy to the nearest degree. B, how high is z above the ground? Giving your answer to the nearest meter. So if we extract this triangle, so we're going to say in, but what we notice is that since the angle that we're going to calculate is this, and because this is the angle between x, y, and xz, then which of the rules are we going to implement? Is it the cosine rule or the sine rule? If we go by what we have here, if you're going to use the cosine, if you're going to use the sine rule, two angles and an included side. So this angle is given, but this side is not given, and this angle is not given, but this side is given. So we can't use the sine rule in this case. Rather, the cosine rule we are going to use first to get this line xz, and so in triangle x y z, triangle x y z, two sides and an included angle is given. Hence, using cosine rule, so we're going to use cosine rule to get this side first, then we use sine rule to get this angle. So this is a case where the use of both the sine and cosine rules is necessary. So from the question, you were not told to use cosine rule first, but you would know by analyzing the triangle or the information given to you whether you ought to use cosine rule first to get a side, then that would enable you to be able to use the sine rule. You would know. So this is a case like that. So we're told to look for angle, this angle here, but from what we are saying, we can't use the sine rule to get this angle. So what we can do is to first of all know this side, then we can have a ratio of a known angle and a known side, and then a known side against an unknown angle, so which is the use of which in this case the sine rule is applicable. So first thing, let's get to know line x z. So using the cosine rule, we're going to say line x z squared is equal to line x z squared, which we can call y, is equal to 12 squared plus 14 squared minus 2 times 12 times 14 times cos 110 degrees, and this will give me 12 squared is 144, 14 squared is 196 minus, let me confirm, 14 squared 196, 2 times 12 times 14 times cos 110, that will give me, so this will give me minus 114.992. Cos 110 degrees, since it's negative, it shows that cos is in the second quadrant, and the second quadrant cosine is negative, that's why the value is negative. So minus times minus 1 will give us plus. So this is equal to 144 plus 196 plus 114.92. So we add everything together, 454.92. So let me say, take square root of both sides, take square root of both sides. Okay. 9x z squared 154 times 92. So answer this line xz is equal to 454 21.3333. So I'm going to approximate to the nearest whole number. So line x z is equal to 21, approximately 21 to the nearest whole number. Okay, so now I've gotten x z, but this says we should calculate the angle between xz and xy. So this side was necessary for us to be able to get this angle, what we're required to get in A. So now that we've gotten xz, let's solve for what we were asked to get, which is angle x, the angle between xz and xy. So to do that, we're going to use the sine rule. Using the sine rule, so now we know this angle on this side, so we're going to use that sine y over y is equal to, and now x over this side, sine x over x. So let's put the figures. Sine y, sine 110 degrees over 21.33 is equal to sine x over 12 meters over 12. So sine x is equal to 12 sine 110 degrees over 21.33. The sine x is equal to sine x give us 12 sine 110 divided by 21.33, 0.5287. The x is equal to x sine 0.5287, and x is equal to 31.92 degrees. So therefore the angle between xz and xy is 31.92 degrees. That's the angle B. This says how high is z above the ground, giving your answer to the nearest meter. So here we're going to draw the diagram again to fit into what we're told to calculate. So remember that x is the ground level. So let's have something like this, and then like this, and then from at this point we have this here like this, and then we have this part coming down. Okay, this is the load. So now I want to know how high z, which is how high z is from the ground, not the load necessarily. But for us to know how high z is from the ground, we can know how high z is from the load, and then plus how high the load is from the ground. So this will give us something like this. So here is 90 degrees, here is 90 degrees, and then so remember here is 12 meters, and here is 14 meters. I write it here, 14 meters. This runs here from here, x, y. So this is x, and this is y, and this is z. Let's call here P, and let's call here Q. So this will be the diagram that we're going to have. Also, this is 90 degrees. So, okay. So take note of that. For us to be able to solve to get how high z is above the ground, what is z we are looking for. So p itself is also high from the ground, and this, if you from this diagram here, if you bring it this way, we're going to find out that p is some distance from the ground, as well as z is also some distance from the ground. So to be able to get the total distance from x, the total distance of z from x, you just need to get z from this load, and then from the load, the distance of the load from x. So z angle z angle z angle y z angle yx equals 110 degrees, which is the total angle from here to here. Z angle yx is equal to 110 degrees, but z angle yp then, let's say then z angle yp, which is this angle here, will be 110 degrees minus this part is 90 degrees. The total angle here is 110 from here, 110 degrees. So this 110 degrees is just like you have something like this. Oh, sorry, have something like this. So if you split it, you're going to have a right angle here and this angle. But in this first diagram, it was totally like this 110 degrees. So if here is, let's call it p, let's call it, before we know that here is x, so let's call this x. So x plus 90 degrees is equal to 110 degrees, which is the total angle here. So to get x will be equal to 110 degrees minus 90 degrees, and x will be what? So 110 minus 90, that's 20 degrees. X is 20 degrees. So this part is 20 degrees. 90 degrees, that's equal to 20 degrees, which is what we are getting here. Required height is, what were we told to calculate? ZQ. The required height is ZQ or QZ. As from here to here, because the question says how high is Z? How high is Z above the ground? And from our diagram, for us to get the height of Z from the ground, or the distance of Z from X, or from point Q, which is the ground level, you know that QZ is equal to PZ plus PQ. So now PQ is already known, which is 40 meters. From here to here is same thing as from here to here. So if here is 40 meters, and remember your 40 meters was from here, x, y. So 40 meters. So PQ is already known. So what we need to know is PZ. So in triangle PYZ, in triangle PYZ, using the cosine ratio. We are using the cosine ratio because we are considering this part opposite and hypotenuse. So using the sine ratio, we're going to have PZ, or sine 20 degrees, is equal to opposite, which is PZ over 12, and then PZ is equal to 12 sine 90 degrees. PZ is equal to 12 sine 20. That's equal to 4.10 meters. So P is 4.10 meters. Therefore, remember that the required height is QZ. Therefore, QZ is equal to PZ plus PQ, which is equal to PZ, which is 4.10 plus 14 plus 14. So QZ is equal to 4.10 plus 14 will give us 18.10 meters. So QZ is equal to 18.10 meters. So therefore the Z is 18.10 meters from the ground. Meters from the ground. So alternatively, we can say we can, from our first diagram here, we can just have something like this. These are X, the ground level, and this is Z. So to form this is what we want. Okay, and then let me extend here. So this is X, and then this is Z. So XZ. So XZ here from our calculation is 21.33 centimeters. Centimeters. Okay, so it's 1.33 meters. But you can have here, so this is XY, and from somewhere XY, so from here, from here curve this, so from here we can have YZ. But this is XY here. And remember the angle between X and Y, which is between X and the vertical from your question, the A part. The angle between XZ and XY was 31, what is it? 31.92. So let me write it here. 31.92 degrees. So this is the angle between X and Y, which is this angle here. Okay, so what we notice is that this angle is alternate to this angle here. This by alternate angles, we have here to be 31. That's here, 1.92 degrees also, and this is 90 degrees. So what we're looking for is Z, distance of Z from the ground. So let's call here Q, ZQ. Okay, so now alternatively, P, Q angle X, Q angle XZ. Let me put this way. Q angle XZ is equal to Q angle ZX. Q angle ZX, and that's equal to 31.92 degrees. What's the reason? Let me say alternate angles. That's the reason. I'm supposed to write it here, but I've already drawn the diagram here, so I'll put it on that. Okay, so with that said, using the cosine ratio, so this is adjacent hypotenuse. Using cosine ratio, cos 31.92 degrees because adjacent is QZ over 21.33. So QZ is equal to 21.33 times cos 31.92 degrees, and QZ is equal to 21.33 cos 31.92, 18.10, so therefore the height, therefore Z is 18.10 meters from the ground. So both answers are the same. In the diagram, Q angle PR is equal to P angle TR, which is equal to 90 degrees. So line PR is equal to 8 cm and line QP is equal to 6 cm. Find line TR. So our interest is TR. So from triangle PQR, from triangle PQR, discover that in triangle PQR, angle P is 90 degrees because of this side. So if it's 90 degrees, to get QR, we're going to use Pythagoras theorem. Using Pythagoras theorem, QR squared is equal to 8 squared plus 6 squared. QR squared 64 plus 36. QR squared is equal to 100. So Q R is equal to square root of 100. QR is equal to 10. So QR is 10. Makes sense. Next, on triangle PQR, applying the sine rule. We're going to have so this is 90 degrees is known, so this angle is known, and QR is known, which is 10 meters. So let's neglect angle R because we already know this side opposite angle R. So we use sine rule to find this angle. So sine P over P is equal to sine R over R. Sine 90 degrees over P, which is 10, equals to sine R over 6. So sine R is equal to 6 sine 90 degrees over 10. Sine R is equal to 0.6. So R is equal to arc sine 0.6. R is equal to 6.87 degrees. So why they look for R and not Q? We look for angle R because the question says to find TR. So first we got to find. So first we use, since we knew that this angle here is 90 degrees, so that means we can get a right angle triangle from here, which P will not look like this. So PQR. So this is, since here is 90 degrees, the angle between PQ and PR, so 90 degrees. So okay, P is 90, so P is 90, QR, so P 90, so PQ would be 6 meters and PR would be 8 meters. We look for the hypotenuse, which QR, which is 10 meters by Pythagoras theorem. Now CR is still here. Then the general triangle now has two sides given and then an included angle. So but we needed to know CR. So what we needed to do was to find this other angle, to get one of these angles known, and the only one that will favor us is this angle R, because once we get it, we can separate this triangle to PCR, where this now becomes a right angle triangle. PCR is a right angle triangle. So with this angle known and this side given, we can use the trigonometric ratios to get TR. So R is 36.87 degrees. The next is a right angle triangle. In right angle triangle PTR. Right angle triangle PTR. Right angle triangle PTR, we have something like this. 90 degrees to E, and this R. Now this angle here is 36.87 degrees. 36.87 degrees. Good. We are looking for this side. Now this line here is 8 meters. PR is 8 meters. So using which ratio are we going to use? Since we are looking for this side as adjacent over hypotenuse, that's cos, using the cosine ratio. Remember, cosine ratio is different from cosine rule. Cosine ratio is your trig ratio from your trig ratio, which is so here this is the C is cos theta. The theta is the angle and A is adjacent and hypotenuse. That's your cosine ratio. So using the cosine ratio, our adjacent is T R over hypotenuse 8 and then cos 36.87 degrees. So TR is equal to 8 cos 36.87 degrees and TR is equal to 8 cos 36.87 and 6.40 meters. 6.40, which TR approximately 46 meters to the nearest whole number.